in the positive y direction and back to its initial position. The element of the rope to the right of this end also begins moving, but with a time lag. Element after element of the rope begin moving in the positive y direction and back to the initial position, just the same way as the left end of the rope. Each element is disturbed by the neighbor to its left, and it in turn disturbs the neighbor to its right. A vibrator disturbance, a crest, travels along the rope. This time the left end of the rope is moved in the negative y direction and back to its initial position. Again, element after element of the rope begin moving in the negative y direction and back to the initial position. Farther the element from the left end, greater the time elapsed before it begins moving. It is a trough now that moves along the rope. If the left end of the rope completes one oscillation, one wave travels along the rope. If it is a continuous oscillation at the left end, wave after wave propagate along the rope. Oscillations are in the y direction and the wave is traveling in the x direction. This is a transverse wave. A long tube has a piston at the left end. The tube contains air whose density is same everywhere in the tube. Random thermal motion of the air molecules does not affect the distribution of air, and the air layers can be represented as being equidistant. If the piston is moved rightward and back to its initial position, layer immediately to the right of the piston is disturbed first, and layer after layer move right and then back to their original position. Each layer begins moving at a different moment, depending upon its distance from the piston. This results in a pulse traveling to the right, whose leading edge is a compression. If the piston is moved leftward and back to its initial position, each layer moves left and then back to its original position. Layers farther from the piston start to move later. You can see a pulse traveling to the right, whose leading edge is a rarefaction. If the piston is vibrated continuously, compressions and rarefactions travel to the right. At any given moment, different layers have different speeds, and so they approach or recede from each other, leading to these compressions and rarefactions. Each layer can be seen to oscillate about its mean position parallel to the tube, and the disturbance propagates parallel to the tube. This is a longitudinal wave.